Hi everyone, we're going to do a bit of an algebra review today, and we're going to go over the order of operations and also how to rearrange equations so that we can solve for a variable. So the first thing is the order of operations. You might know this as PEMDAS. We do parentheses first, then exponent, multiply, divide, then add and subtract. And we do this, we follow this order whenever we have all of the numbers and we're trying to solve our equation. So in this case, we would do whatever's inside parentheses first, the 2 plus 4. Then we'd go to the exponent, so we'd square it. There's nothing to multiply and divide, so then finally we would add the 9. And our answer would take the form of x equals some number. Now, what we're going to focus on is working in the opposite order, backwards, so that we can rearrange an equation to solve for a variable. This is something that we do all the time in physics. So for example, we have an equation like this. There's no numbers in here. We need to solve for the variable a. So we would work in reverse order to solve for our variable. Our answer would just be a equals and then some combination of the variables that were originally given. Things to remember when you are rearranging equations. You're going to work backwards when solving for a variable. We need to do the opposite operation to move the variable. So if something is added, you would subtract. If it's multiplied, you divide. And you'll see this as we work through our examples. We need to make sure we do the same thing to both sides of the equation. And if the variable is in the denominator, move it first. Multiply by the reciprocal to move a fraction. So if you keep these 5 things in mind, it'll make things a little bit easier for you. So now you want to make sure that you have out your examples handout so that you can work along with me while we're doing these. So for example 1, d equals 55t. So when you see two variables or a number of variables squished together, it means that we're multiplying them. So if I'm trying to solve for t, the opposite of multiplying is dividing. So I'm going to divide both sides by 55. 55 is what I want to move over to the other side, get it away from the t. So 55 divided by 5, that's going to cancel. And so my answer is d divided by 55 equals t. And I'm going to box my answer. Okay. Number 2, I want to solve for x. Y equals x minus a. So I need to get a over to the other side. I see that it is subtracted, so the opposite would be to add. So I'm going to add a to both sides. And so now over here on the left side, I have y plus a equals x. Okay, same idea here, y equals 13 plus a. I need to get 13 over to the other side. Be careful here because you might think that you should subtract a. And all that's going to do is just bring it over to the other side where you have y. So then you'd have y minus a equals 13, and that's not really helping you get a by itself. But if we look at the number 13 here, it's really a positive 13, so I can just do the opposite to get the 13 to move. So I'm going to subtract 13 from both sides. So that would give me y minus 13 on the left side, and then a by itself on the right side. Okay, for number 4, y equals bx minus c. So here, I have 2 operations that I'm going to have to do. I can see it's b times x, so I know I'm going to have to divide by b to get rid of that. And then minus c, so I'm going to add c to move it over to the other side. Which one do I do first? Remember our order of operations, and we're working backwards. So we're going to add and subtract before we multiply and divide. So that means I'm going to add c to both sides. And then I'm going to divide by b. So then my final answer should look like this. Y plus c over b equals x. Okay, here's another one, a little bit more complex. We're going to solve for v1. sometimes when you have a lot of variables, it helps to circle or underline the one that you're trying to isolate. So you can see we've got a fraction, we've got parentheses. Remember, leave whatever is in parentheses till the last. So that means that we need to get rid of the 1/2 and we need to get rid of the t. So remember, to get rid of fractions, we're going to multiply by the reciprocal. So I'm going to multiply by 2 over 1, both sides, 2 over 1. So that means I have 2 times s, the fraction canceled out. I have v1 plus v2 in parentheses times t. Now I'm still dealing with everything that's outside of parentheses, so I'm going to divide by t. Rewrite what we have. 2 times s divided by t equals v1 plus v2. And now I've got rid of everything else outside the parentheses, so I can get rid of parentheses now. The final step is to get rid of v2. So I see I have it added, so that means I'm going to subtract v2 from both sides. And so I'll write this over here. I have 2s minus t, and I'm subtracting v2 equals v1. Okay, these are going to get a little bit more challenging. Just pause as needed. Okay, here I'm going to solve for m. A equals f over m. And now your first thought might be, okay, I need to get rid of the f, so I'm going to divide both sides by f, and then that gives me m. But m is in the denominator, so if you do that, you wouldn't be solving for m, you'd get 1 over m. That's why in the notes they said it's best if you are solving for a variable that's in the denominator, move it out of the denominator first. So that means I'm going to multiply both sides by m over 1. So here, that leaves me with m times a equals f. Now I can get rid of the a. So I divide both sides by a. And that gives me m equals f over a. Let me show you what would have happened if I had worked with the f first. So we'll go back to our original equation, a equals f over m. And if I said, all right, I want to get rid of the f, so I'm going to multiply by the reciprocal or divide by f, same thing. So I have 1 over f. That means f cancels out over here, and on this side I have a on top, f on the bottom. And then on the right side, notice m was in the denominator. It stays in the denominator, so that means now I have 1 over m. Notice these aren't the same things, a over f, f over a. So here I would have to do one more step. I have 1 over m. I would need to flip my fraction. So this would be m over 1, and this would be f over a. And then the 1 would just cancel out. So now this would get me that final answer that I'm looking for when I solve for m. Okay, let's try another one. We're going to solve for t. I have parentheses, a equals vf minus vi over t. I don't need to worry about anything in parentheses because I'm solving for t, and that's outside of the parentheses. I'm going to multiply both sides by t so that I can get it out of the denominator. So now I have t times a equals vf minus vi. And I'm solving for t, so last step, divide both sides by a. I should add those parentheses again. And so here's my final answer. Okay, last one, dealing with exponents. I want to solve for v, and it's v squared in here. Let's rewrite our order of operations so we can remember. We're going backwards. Okay, so the last thing that we're going to do, since we don't have parentheses, we're going to deal with that exponent. But that comes after add, subtract, multiply, divide. So first, let's get rid of the fraction. Multiply both sides by 2 over 1. So I have 2k equals mv squared. Then I'm going to divide both sides by m to move that over. And then the last thing, remember I need to do the opposite operation to get rid of something. So the opposite of squaring is to take the square root. So I'm going to square root both sides. So that means over here I would have v, and then on this side it would be 2k over m, and the whole thing gets the square root. And that is my final answer. And so those are your 8 examples, and those should help you with your problems.